Alright, ladies, it is Sunday, September 10th. We're gonna go straight to it, and today we're gonna be talking about CSV files. If any of you are familiar with those, we're gonna open one right now. Make sure you separate by comma. If you are using OpenOffice, Note++ is also pretty good. So what we got right here is a GM Crate 602 engine. That's supposed to be making around 350 horsepower around there on paper. Anyway, let's take a look. This one is not gonna look like your regular CSV. This is my own. You start basically from an empty one where you delete everything out of it and then you just copy paste the stuff that you're working with, so it doesn't look that messy. Let me show you its features. So we got RPM 1 and torque 1. Let me just color it because I know people like colors. RPM and torque 2 right here. RPM and torque 3 we got as well. So we got the whole power band right here. Engine mechanical dimensions. Now you don't want to fuck with those because these are real deal hardcore numbers. Find them off your engine and you could straight transfer. What you got here is your stroke dimensions. Oopsie. Okay, so we got our stroke, cylinder displacement. That's how big your engine is. That will define our bore as well, because you know bore times stroke times whatever equals cylinder displacement. Doesn't matter, but so we also, the computer also knows the bore as of this point, if it makes any sense. Number of cylinders, of course, 8 cylinders. Number of intake valves and the size of the intake valve. Those of you that are familiar with what an intake valve is, no questions asked, but if you don't, strongly encourage you look up what an intake valve is. Red line. And this is a very important value because not only it is a red line and a rev limiter that's gonna make your engine go whack, 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 it also hella affects the horsepower that you're getting. So the whole torque curve and the way the game builds the torque curve dramatically depends on the red line value that you got. The closer it is to your max torque, right here, I mean not max torque but torque 3, the more power you're gonna get. The farther away you move the red line away from your torque 3 value, that shit is gonna rob you on power all the way through your curve. Like, I haven't figured out yet exact way to kind of draw it and show you on a drawing how it's gonna look, but basically also in the article I read that sports cars or race cars have their red line within 200-300 RPM of their max horsepower, as we see right here. Classic example, 9,000 maximum horsepower for our stock values on our cups, and 9,300 RPM as well as 73 right there on each one. It's plus 300 RPM just like by the race book, if it makes any sense. Anyway, red line values for now set at 6,000. The max horsepower that we're making is at 54 by the stats, so we're about 600 spread apart. However, the maximum recommended RPM for this engine on the website is 5,800, so it'll be only 400 apart from where the max power is made. Anyway, if any of you understood any of that stuff, let's see. Peak power. Now, peak power is not peak power, it's not your peak horsepower, it does not affect jack shit. Let me tell you that. We're gonna dig into that because here you see variations, so something changes, something matters. As well as peak power, as well as carburetor flow CFM, you know, carburetor CFM, the airflow, cubic feet per meter, whatever. I have a theory, let's just guess that it might be both or none or whatever, but it matches about the same, about 350 horsepower and about a 350 CFM carburetor if you run it, but honestly changing this value does not really matter whatsoever. Then these two nobody ever messes with. I don't know, this is like some kind of race control for qualifying or race qualifying engine. Does not really matter, nobody ever messes with those, but they are included just, you know, as a copy paste. Oil and water cooling values are being decreased, but this is all for testing. If it needs more cooling, we're gonna work it out. If it needs less, just wanna throw it out there. We are still running a 4-speed transmission, just like stock physics would, but that could be changed at any moment. And these are your transmission control gear ratios. This is very important if you want to do cool stuff in the engine. By default, this gear was locked like this from 0 to 34. So you had adjustments of 34 clicks. From click, 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 click. Each click is a field. Now if you change them to 68, like that, repeating this pattern from 0 to 68 in a step of 1, right here, here, here. If you do all the gears like that, oh, actually here, should change that to 0 to unlock the 4th gear, but this would allow you to unlock each gear range going from all the way from minimum to all the way maximum, because some of the like 1st, 2nd and 3rd gears are limited on what you can choose, as well as the other gears are limited, but they're on the other side, you know, they're limited from the other side. Same with the differential. From 0 to 148 in steps of 1, you have 48 different adjustments for differential. It's 48 different clicks. If you want to skip some, steps of 3 or steps of 5, and it will skip steps, you're gonna have very fewer clicks, and it will skip four fields each time. You whatever, more separate video on that later. Anyway, here we went through the whole profile and what I got in my CSV for now. Late model project. Let's write down the freaking money numbers. Money tuner. Alright. So we dealing with, oh come on, about 105 at 0 RPM. That's torque 1. We're not talking about torque 1. Torque 1 is a specific deal. We're gonna talk about that later. Well, we're talking about max torque and max horsepower figures. Max torque, RPM 3800 RPM. We are making 170.6. I want to take your attention right here. PSI, pressure, PSI, pounds per square inch of piston area. Okay, now remember that piston has an area, and then the pressure is pushing on the piston. There you go, PSI. On the second value we got 5400 RPMs, and we're making 446.6 PSI. Now quick formulas that you want to run, and we've been over this, but this is a late model project, guys, starting from scratch, and the engine is the first part that you want to do. Let's go. 150.8, that's the magic number, okay? Times your torque equals, times your torque divided by your CID, that's your cylinder displacement, the size of your engine, equals your PSI. Okay, now if we need to find torque, that would equal PSI times cylinder displacement divided by 150.8. Makes sense? Maybe for some of you it does. Let's go just run the calculator on that. What's our PSI up top? 170.6. 170.6. Now with times, this is a 350 engine, 350, Chevy 350 times 350 divide 150.8. How much torque are we making? We're making 395.9. Let's say 396 foot-pounds of torque. Let me put that right here. 396 foot-pounds of torque. Get that shit in red. Torque. Yeah. Now let's do the same thing and see how much torque we're making right here. That's not gonna be our horsepower, but we need torque to find out horsepower. 146.6. If you followed me here, right here, our PSI times Chevy 350 divided by 150.8. That's the magic BMEP number. You can look that up yourself. 340 and a quarter. 340.25 foot-pounds of torque. Now you need to remember this formula. Horsepower equals, okay, that's a very simple one. We're not gonna run the complicated one. Horsepower equals torque times RPM divided by 5252. That's the magic number. We're gonna run the math on that. Come back. Run the math on that and go. 340 and a quarter foot-pounds of torque times, what's the RPM? 5400 divided by 5252. That would bring us to 349.8 horsepower. 349.8 HP. Alright, that was the math. Horsepower in blue, approximately 350. Okay, we could put that at 350. So our engine stats end up to be 350 horsepower at 5400 RPM and 396 foot-pounds of torque at 3800 RPMs. Booyah! Correcto? Somewhat. Here's the formulas and the explanation. We're gonna go on Reddit. Post your edit on Reddit. And where is this? Street stock model engines introducing. They advertise stock numbers for this engine. CT350, GM602, 350 horsepower, 396 foot-pounds of torque. Let's take a look at our page. Boom. All the calculations, all the numbers have been done for you there. That's the engine profile that you want to run. And these are the PSI, BMEP1 and BMEP2, torque 2 and torque 3, and RPM 2 and RPM 3 are right here for you. That's the stuff over here that we are running. These are the numbers for our CSV for the 602 engine. Next, money shot. We're gonna make an EXE, take it around Urbandale, record telemetry, and see how much of that power, supposed to be 350 and 396, we're actually delivering to the rear wheels of the car in different gears. But that video is gonna come next. Basically, we made an engine, we're gonna go and drive it, and we're gonna see what the engine is putting out using replay analyzer. Before I go, just type in on Google NR2003 replay analyzer, and the very first website will take you to this magnificent download page where you can get the free tool and use this thing yourselves. For now, I'll be out. Peace, everybody. Keep it cracking.